Welcome, everyone, to episode 1 of Zeet's Platform Engineering Podcast. I'm Johnny Dallas, your host. I'm the CEO and co-founder of Zeet, and today we're going to be talking with Viktor Farcic of DevOps Toolkit. Viktor has spent a lot of time in the platform engineering space, and today we're going to be talking about platform engineering. What is it? Why should one do it? When is it a good fit? Just to get us started, Viktor, would love for you to give a quick introduction. Who are you, and what do you know about platform engineering?
Yeah, so I'm Viktor. I'm a developer advocate at Upbound. And then on top of that, I have a few hobbies like writing books or hosting a YouTube channel, podcasts, and things like that.
Yes. Just to get us started, to get a little bit of kind of context on you, Viktor, why platform engineering? Why DevOps? You create a bunch of content around this space. What was what got you started here?
Laziness. That was the main motivator since I started this career, right? I was never happy doing mundane, repetitive tasks that I don't want to do. So very early in my career, I was focused in some form or another in automation. Either automation or enabling others to do my work, or both, depending on the situation, right?
and that's the crux of it, truly. I mean, this is an industry where the titles have changed so much over time, right?
I would even go as far as, if I would be recruiting right now, I would ask people how lazy they are, right? If they do everything that they're supposed to do instead of doing everything that in a direction of making them obsolete and not doing stuff, that would be a better option always.
What's the Bill Gates quote around this? You always put the hardest challenge with the laziest person because they'll find the easiest way to get it done. I think that's like a philosophy that applies really well generally across tech and computer science, but especially in DevOps, where you have more and more jobs to do and fewer people to do them. It's all about the ops piece. How do you support developers? How do you get more done with less people? There's a lot of people talking right now about this rising trend of platform engineering. A lot of people are saying it's the death of DevOps. For those unfamiliar, could you just give a quick explanation? What is platform engineering? Is DevOps dead? Is this the future? How do you see this trend?
No, DevOps is definitely not dead. I just think that it is greatly misunderstood, mainly because of vendors. And I'm one of the vendors. We all do that, right? We put stickers on random things because they are in a hype right now. And I tend to define DevOps as a cultural change where, as a result of that change, a team should be able to be in full control of what they're doing. Meaning not only writing code, but also everything else all the way until production, right? From my perspective, you can even say that AWS two-pizza team is kind of a personification of DevOps, right? So that means that developers should be able to write code for their application, of course, but also tests, should be able to build it, should be able to deploy it in different environments, including production. So I see DevOps as a way how to create those self-sufficient teams. Now, I'm not saying in any formal way that a single person should know everything. What I am saying is that a single team should be in full control of the whole life cycle of an application. And from that perspective, I think that DevOps is a kind of extension or continuation of what we started with Agile, right? Before Agile, there was that clear separation. I write code and then somebody else tests it, right? And then we got teams that slowly but steadily took all those tasks into one team, right? We rarely see testers as being a separate group where you develop something and then you throw it over the wall to testers and then they tell you how bad it is what you just did. If that makes sense, then DevOps is just continuing the trend because Agile teams never managed really to take control of things. They just managed to take a bit more control, right? oh, I can now develop and test, and then I have no idea what happens afterwards.
Yeah, and I think that really is the problem with Agile. How can you really expect a team to test software that they haven't written? That doesn't really work. Amazon talks about the 2 pizza team. Have a team the size that no team bigger than what could be satisfied by 2 pizzas, and all the expertise for a given piece of the business needs to be contained within that. And I think platform engineering is really what makes that scalable. Every job has to be done. That doesn't mean that every developer has to do every single job themselves. It's about scaling that expertise. We have new verticals coming out in the DevOps world every day. Supply chain security, that didn't exist 2-3 years ago, and it's incredibly important now. How do you go from this new vertical popping up, scaling that expertise to the entire team? How can you expect every single team to have an expertise in supply chain security when it didn't exist when they started? I think this is especially relevant for small teams that can't afford one person per resource, and they really need to make do with what they have. Platform engineering really just feels like scaling expertise across the board here.
So the answer to that question depends on the last part of your sentence, small team, right? Whether it's a small team or it's a bigger medium-sized team, or actually not a team, a company, right? Rather than a team. Now, if I start from the other direction, if I say, let's start with bigger companies, right? I do completely believe that the direction should be in those self-sufficient teams. But what we cannot do is repeat mistakes from the past with full stack developers, right? I never believed that that's a thing or useful thing, and I still don't believe that's a good thing. Because you cannot know everything. That's simply silly. It's enough. You can easily spend 10 years in just writing Java code, and you still did not figure out everything, right? And extending that, and I'm going to do front end and back end and database and everything, that's just not going to cut it. And now that's a bit conflicting because I just said full stack developer is not a thing. But then DevOps is a thing, then because and it has even bigger scope than what previously we knew as full stack. And the key there, I think, is in everybody who is not in a team that develops a specific application, customer-facing application, should be in a team providing services to those teams, right? So you're a person who has 15 years of experience with databases. You know exactly how to create, install, configure, do everything with a database. Excellent. I cannot expect people in application teams to have that level of experience, but I can expect you to create a service that those teams will consume. So what AWS is to ops, I think that those other teams should be to everybody else within a company, right? You should be providing service. You shouldn't be doing the job for somebody because that does not scale, right? If you're a person who is in charge of, let's say, creating and managing clusters for others, then the bigger the number of requests is for those clusters, the more people I need. And that does not scale. Now, if you can create a service and say, hey, those are all the Jira fields. And the reason why I'm saying Jira fields, you know how you had to create a Jira ticket and provide all the information that I need to create that something for you? Now I can create a service that you can actually use let's say YAML, define those fields, and say apply, right? You don't need me because you're already providing the information that is required for me, and if I create a service that you can consume, off you go. My job becomes made to be a maintainer of that service rather than a person who does things for you. And that's the birth of what today we call platform engineering, even though we had it for like 30 years, something like that.
Yeah, I really see how this bridge to Jira is almost the start of platform engineering, this standard API to create anything. It's a way for application developers to go in and request, hey, I need a DNS record, or I need a new SSL cert or something else from an expert team. And I'm not advocating for ticket ops. I think ticket ops has a lot of flack for very good reasons. It's long delays, wait 48 hours, never hear back. All sorts of problems can happen in there. But it's the right model. It's the start of, I think, what platform engineering turn into. Victor, I hear you on this myth of the full stack engineer. It sounds like you don't really believe in full stack engineers. There's more and more jobs to do, and that's increasing over time, and that just doesn't scale. It sounds like you're advocating for a team more like every team is a two-pizza team, service team dedicated to providing a service, almost analogous to what RDS is on top of AWS. Kind of sounds like you're advocating for teams that are just building their own internal version of a cloud provider. Maybe you have like a database team here that knows how to run databases very well, and that's their expertise, and they provide that as a service to the rest of the company. And that's part of the developer platform here that we're talking about. Is that a fair analogy, developing an internal cloud platform like that?
Yes, something like that. I'm advocating for people being specialized and doing something really, really well, whatever that something is, but being able to get everything else they need without opening Jira tickets, right? I do not need to be an expert in database to know that my application needs a database and that I have a schema that should be applied to that database, and that database should conform to certain standards within my company, right? I do not need to be an expert to know that I need that. I need to be an expert to set it up, but that's where platform engineering or any type of service providing services comes into play, right?
Yeah, and it's all about scaling expertise. I'm curious. You make a really good point here that Jira kind of enables this platform engineering today. And the DevOps space is, with lots of titles, have changed a lot. So we won't dig too much in the ticket ops world. But I'm curious. Given some of these philosophies have already been possible, but they haven't really been dubbed this moniker of platform engineering, or it feels like there's more substance to platform engineering than just using Jira. How do you think about what's the big change that we're going to see in the next couple of years? How would you say the world of today, the world of DevOps versus the world of platform engineering? What's that shift going to look like?
I think that the major difference is Kubernetes. We had teams that create services for others or somehow help others in one way or another forever. I've been involved in quite a few engagements where, and I'm talking now a long, long time ago, working with teams that provide Jenkins as a service, like, hey, we're going to create some generic jobs you can choose from, or one huge job that will be parameterized, and somehow you can define your own pipelines without really going in too deep into it, right? Just the right level of what you need, not more, not less. Now, the difference between then and now is Kubernetes, because we finally have an extensible platform on top of everybody puts their own solutions. We have a single place from where we can do things, right? Before, if I would be providing the services or platform that I'm referencing right now, it would not work if somebody needs to, there is, for pipelines, there is Jenkins, and then go and figure it out, and we're going to help you, but it's one thing, and then go to Ansible for something else, and then go to Terraform for something else, and so on and so forth, right? Just making it slightly easier, slightly nicer, but not really good. What I want is a similar experience an operator would have in a company that uses exclusively AWS. Hey, AWS is where I go to accomplish things. I don't go to 75 different platforms or tools or whatever. That's my focus, right? And Kubernetes is simply built for that. Very early on, it got the concept of custom resource definitions, which allow anybody to define anything. You can say, hey, I have XYZ, and I want to have XYZ, whatever that something is. I create a new custom resource definition, and all of a sudden, Kubernetes knows what XYZ is, whatever that is, right? I can make those interfaces that are exactly tailor-made for what somebody needs, instead of saying, hey, just learn HCL. right? And off you go. And after that, why don't you jump into Jenkins, Java, whatever is the language that Jenkins uses? My brain stopped now. Figure it out.
Yeah, that's a good point. And I really like how you're using Kubernetes here as a unified compute plane that can really do a lot. I think that's really interesting. There's almost an analogy there to a shop that's fully on AWS. They have an AWS service for everything. You've got RDS for databases. You have S3 for block storage. You've got KMS for encryption and security there. EC2 for compute. I'm kind of curious that one trend that we see outside of platform engineering, but very much adjacent, is this trend of multi-cloud. And I think we're seeing more and more teams deploying across multiple clouds at the same time. And one of the biggest reasons that at least we see that is to leverage the different services that different clouds have. You might want to use SageMaker over on AWS and some compute offering over on GCP, and you want to save money on your bandwidth bill over on DigitalOcean. Maybe you've got some crazy OpenAI project coming up, and so you need to use Azure for that, stuff like that. I'm curious, do you think that with multi-cloud growing and platform engineering growing, we're going to see some intersection here? Do you imagine that we'll have a AWS console that sits across your clouds, or are we heading in a different direction?
Still the same answer, Kubernetes, right? We can extend it through custom resource definitions and controllers, and those controllers can do whatever you need it to do, right? Whether that's, hey, I'm going to interact with AWS to do this or that, or I'm going to interact with Azure, or I'm going to interact with Alibaba or Google or anything else, right? So again, that's vitally, basically everybody in the industry considers it a standard right now of some sort of another. It's extensible. It's there, right? That's the entry point to manage resources, right? I don't see Kubernetes as a thingy that is designed exclusively to run containers, right? It's an extensible API with controllers and all the other good things to manage resources. Now, whether that resource is a pod that ends up having one or more containers, whether it's a virtual machine running in that same cluster, or it's a virtual machine running somewhere else, or even better example would be an external load balancer. People have been using Kubernetes from the very beginning to manage infrastructure without knowing that they're managing infrastructure, because that's what happens when you create an ingress controller, when you install an ingress controller. It is managing your external load balancer. You just might not know about it, right? And one more thing that I like to mention whenever we talk about multi-cloud, because usually there is somebody listening to this right now and thinking, yeah, but I'm not multi-cloud because I'm using only AWS or only Azure or only Google, right? And I have no plans to go to other two. And I will say that that's not true. Let's say Datadog is that cloud? Is it cloud service? GitHub, is that a cloud service? Right? Or and so on and so forth. So everybody today is multi-cloud. Now, not everybody is multi-hyperscaler, but I don't think that there is a decent company right now that is not using at least two cloud services. And maybe none of those two are AWS or Google or Azure, right? But you're using GitHub, right? Or if you're not using GitHub, you're using something else. You're using CDN.
I guarantee you have a CDN in front. You have Cloudflare or Fastly or something.
Exactly. CDN. There is an example. Show me a company without having a public domain.
Yeah, I very much agree with this point. I think we come up on this point actually in a very interesting way through the course of the work I do on day-to-day. So for context, Zeet helps many early-stage companies provision infrastructure across clouds. And one thing that I did not expect when we started, but we see more and more, is early-stage teams deploying across clouds. I'd say right now about 70 to 80% of our pre-Series A customers are deployed on multiple clouds today. And it's for exactly this reason. It's, I want to go use TPUs from GCP, or I want to use cheap bandwidth from DigitalOcean, like I referenced earlier, or some little pick and choose here or there. But the funny thing about this, though, is they think of themselves as being on only one cloud. They don't think of themselves as being multi-cloud. So I actually think this is actually a education problem.
Exactly.
We need better tools and better education about what is your entire stack. Outside of GitHub and infrastructure as code, what do you have to unify this experience into one place? One thing that comes up when we talk about platform engineering is personas. I think we have to define who we're talking about here. The first persona that usually gets defined is the application developer, the consumer, the person who cares about business logic. They just need to build services, write code, and iterate really quickly. Probably a little bit broader of an expertise, more than a deep expertise in one single area. The other persona that we talk about a lot is platform engineers, or, previously in the past, they were called infrastructure engineers or DevOps engineers, or a million titles in there. But, these engineers who are dedicated to internal operations in some capacity, they have a deep area of expertise around a certain part of the business, and their focus is really on serving the other engineers in the company, giving them access to that deep expertise. And, when we talk about these two personas, what is most important here, and really what makes up the platform, is the space in between them. How do they interact with each other? What does the surface area look like? And I hear many debates on what the right surface area is for a platform engineering team. My personal opinion, if there's a human involved, it's the wrong one. It's not a Slack message. It's not a Jira ticket. It's not a DM. It's not a phone call, please. What do you think the ideal surface area is for a platform? What do you think is the most scalable answer there? Is it a CLI, a website, something else?
To begin with, I definitely don't want to. I don't want to message in any format or any way anybody to get anything. We are way past that, right? But before I answer your question, I actually think that there are three parties involved in platform engineering or building a platform, right? I see platform engineers as a very, very small group of people, maybe only one person, whose job is more to scaffold that platform and rally people around it, right? Because going back to what I was claiming about full stack engineers, right? I do not think that somebody can say, I'm a platform engineer, and all of a sudden I know everything about AWS and Google and Azure, and I know everything about databases, and I know everything about everything. And since I am godlike figure that knows everything, I'm going to create a platform. Again, that's not going to happen. What can happen is that consumers and contributors to the platform are the same people, right? I'm an application developer and I consume the platform to accomplish XYZ, whatever that is, right? And then I'm a database expert that will contribute to the platform by creating a service that others can leverage to create and manage databases, because I don't want to do that for them. I'm lazy. But at the same time, I'm consuming that platform because maybe for my database, I need a cluster, and that's not my expertise. So I'm going to consume that platform to create what is outside of my core competency and contribute with my core competency to that
Totally.
platform. Right?
Yeah, no, that's a great distinction. It sounds kind of like there's, application developers still consuming. Platform engineer, I guess, is more the platform owner, the person thinking about how all these pieces fit together. And how do you find them? Service owners or service devs? It's kind of this third type who's actually creating the services and exposing them into the platform.
Yeah, I mean, experts, right? Everybody is an expert in something, hopefully, right? And you contribute that expertise. Sometimes nobody needs such a contribution, right? Maybe you are just a person who knows how to write Java code, and there is not much you can contribute to the platform. But then maybe you know something, maybe you're an expert in something that others can benefit from. And that's probably the criteria, right? Do I know something that can be useful for others, and I can wrap it into a service and plug it into that platform, right? And my main motivation being so that others do not ask me to do it for them.
So in this world, we have these three personas: the application developer, the platform engineer, platform owner, and the service devs. It sounds like the job of the core job of the platform engineer is to think about this platform holistically, thinking about how do service devs spin up new services and plug those in without having to talk to a platform engineer? How do application developers consume this service? How do they make modification to the settings? How do they see the status of their resources? And we've interviewed many dev teams that have different levels of maturity on their developer platforms, and talked to them about how they solve this problem. How do you build a scalable interface? And we've seen lots of different answers, ranging from a custom UI that we built, to something built on top of Backstage, to custom CLIs, to our friend TicketOps. I'm curious, Victor, if you yourself were a platform owner, you're going into a new company, and you are faced with this challenge of how do you build a platform that everybody will use and can be used holistically, where do you start? What's the first couple things that you do to figure out what the right interface is for your company?
I see every team or every persona in a company serving a customer with clear business goals, right? Now, your customer might be an external entity. You can be an application developer and your customer are the customers of your company. Brilliant. And if you are that, how do you know what to build for that customers, for those users, right? Well, you need to figure it out. You need to ask them, or you need to guess and then give it to them and then iterate until you get just the right functionality in just the right form so that your customers are happy and they do business with you. Now, you can be I'm going to call it internal developer, meaning that you're a developer that builds something internally, right? And in this umbrella, I put everybody else, meaning database experts, cluster experts, infrastructure, whatever, right? You're a developer. You're developing something, a service, and your customers are other internal entities, other developers in your company. So when the question comes, what should be the interface? I don't know. You need to ask them. You need to ask your customers what they need, or you need to guess. But if you guess, you need to be prepared that you will sometimes guess right and sometimes guess wrong. And when you guess wrong, then you change, right? So I cannot answer that question because I don't know who your customers are. Maybe there are people who maybe everybody in your company are terminal freaks and they just want to execute commands from a terminal. There are people who don't even want to use IDEs and they write everything in VI, right? Maybe those are the people maybe those same people prefer web UIs. Maybe they prefer writing something and pushing it to Git, right? You need to find out what your customers need. So there is no answer to that, right? Now, if you ask, what would I prefer as a customer, then my answer is relatively straightforward. I want a declarative format, anything but XML, and I want my interface not to be Kubernetes that I was talking about later. I want my interface to be Git, because Git, from my perspective, is the only constant, right? If you would now analyze what everybody uses, the only thing that we would all agree, that's Git. Everything else varies between people, right? Now, if you are in a company where not everybody uses Git, then you have a much bigger problem than the problems we're talking about right now.
Yeah, no, I love that answer, both parts of it. I very, very much agree with the first part. One of the big changes with platform engineering that we're seeing is, treating DevOps like a product and actually seeing that product-driven mentality coming from DevOps engineers or people who are traditionally called DevOps engineers. And I think this is a really important change because there's no one size fits all. Every company is different. Every team is different. You can't really just put in a one size fits all solution and just expect that to work, which means you need to do user interviews. You need to treat this like a product. Your customers as a platform engineer are not the customers of your business. Your customers are your coworkers. It's the other engineers on the org. You need to go and understand what's limiting them right now. What's the biggest thing I can do to help? How do they like to work? What is the best fit for my company? And I mean, Victor, you've been burned before. You've seen good teams operating. You've seen bad teams operating. I think Git is a great answer here. Storing your configuration in Git, bringing the GitOps philosophy in, just lets you leverage all the functionality of VCS, right? You can see who changed it, when, why with a commit message. You can have instant rollbacks built in.
Yep.
I'm a really big fan of the teams that are putting all of their infrastructure config in code and putting that in Git, even for developer platforms. And I love the point that you're making there about multi-cloud and everybody actually being multi-cloud without quite realizing it. I think there's a parallel here to when we talk to people about what their developer platforms look like. Most teams, when I go and talk to them, don't quite realize they have a developer platform. But one hot take that I'll venture forth with here is I think every single team out there has a developer platform. It's just most of them are shit. Most teams, your developer platform is GitHub and your CTO Slack DM. And that's where you go to do your job as a developer. And so that's your developer platform. I define developer platform here as, the sum of the surface area of the tools that you go to as an app developer to do your job. Minus writing code, I think the IDEs are a bit of an exception here. But if you have to go to your CTO or some guy named Jeremy in Slack to figure out, is my service down? That's part of your developer platform. And if you have humans in your developer platform, that's a problem.
It should be. It's not. When you say logs, I've seen quite a few cases, and I continue seeing where actually the place where you see logs is by calling Joe because he knows. And the place to know the status, what's happening in production, is to go to Michael because he happens to be SRE, right? So that's why I'm saying should rather than necessarily always is.
I mean, in that case, Joe and Michael are part of your developer platform, and that's a problem. You should not have humans in your developer platform, like I said. But that's where you go, and so that's your developer platform. I think the first step is really acknowledging that. And until we do that, how can we make any progress forward?
Exactly. That human platform, right? Kind of. You have people, and they do things for you. If you don't mind, I'd like to go to one previous thing just popped into my mind. When we were discussing about, and you kind of agreed, hey, customers and stuff like that, other people in your company, your customers. One, I think that's actually the major problem. And I think that's where companies have been failing for 50 years, because most of the time that's not the case. Because most of the time, here is how it looks like. You have a platform team or whatever it's called in the past, team that does something to help others. And then they finish doing whatever they're doing with a lot of guesses. And then they go to CTO, and CTO mandates that absolutely everybody, no exception, needs to use that. The moment the moment you make something mandatory, the moment you remove the choice from people, you messed it up. I want to have a platform where nobody is forced to use that platform, and they can just as well do it without that platform or whatever it is. And then I know, okay, so nobody's using this.
Yeah, and that's a great point. I mean, what's the point of DevOps or platform engineering? When we get down to it, the core idea has stayed the same, regardless of what we call it. It's all about how do you help developers develop faster.
Exactly.
It's the core of this entire industry. If you're mandating a tool that devs don't want to use, you're probably not making them faster. There's probably something wrong in there, and there's probably a reason why. And 9 times out of 10, the reason why is I didn't do proper customer research. I've seen so many teams that spend 2-3 years developing some state-of-the-art brand new system. It solves every edge case, it solves every engineering manager's complaints. Everyone's so excited. And the next 3 years get spent trying to get that to 10% adoption. And every single engineering meeting is just, hey, we have this new system. It's going to improve it in these 3 ways. You should switch to it. Please, please, please. We put so much time into it. And it never quite happens. And the reason for that is it's missing the crux of the problem. You're not serving your customer. If it was solving problems that they had, they would just do it. And you might be solving problems that they just don't feel that badly. Your business exists because it solves some problems for your customer. Why are you any different? Just because you're talking about internal customers doesn't change anything. You need to make sure you're actually serving your customers properly. You need to make sure you're interviewing them, understanding their problems, and doing whatever you can do to make them faster, not just pushing some new technology forward. I think this is so relevant here because, like we're talking about, every team is different. There's no one-size-fits-all solution. You might have a team, to your point, that's all terminal freaks and they just love living in the CLI, and that's great. There might also be a team where 90% are new grads and they need a very, very simple web UI so they don't break anything by accident. Both are completely valid answers for how to do development, and it just depends on who your team is, what your goals are, and what your specific situation looks like. And this is why I say it really has to come out of user interviews. It can't come out of a board meeting. It can't come out of some engineering strategy meeting, because too often it does.
It can, but it won't work. Imagine if real world business would work like that, I would be a very, very happy person. Imagine that in my company, we have a product and we have that possibility to say, no, you have to use it. Everybody is forced to use our product for a price. if I could have that power, man, I would take it any time of the day.
We can always dream. I do think this is an interesting topic to think about because there are likely some platform engineers who are listening right now, and likely don't want to fall into the same pitfalls that we're describing here. So I'm curious for any platform engineers who might be listening, what would you say are some of the right things to focus on? It doesn't seem like adoption is the right metric, at least not in a vacuum. Just pushing adopt doesn't quite result in the right outcomes. What would you say is the right KPI to center around, the right number to move?
Actually, I do think that adoption is a key metric if it's willing. If I say, hey, here's this thing that can help you out, use it or not, outside business, right? You have a product, people willingly start using it, and the adoption increases. That's extremely valid metric, right? There is also the frequency of usage of something. People very often pick wrong things to start with. Good, like the examples that I gave before. Hey, I can give you a service to create a cluster and manage a cluster. Yeah, but how often do I create a cluster, right? Database is a better option than a cluster because I have more of those, or I might, right? I'm assuming now microservices, every application has a database type of scenario, right? Or maybe how do we define an application? Like, let's say that you're working with Kubernetes. What is an application? Nobody knows. It's a collection of low-level primitives like, deployment and a service and ingress and virtual service.
And what even is an application? Is it a CRD? Is it a deployment? A bunch of pods? Some combination of the above?
Yeah. Can be, hey, this is application as a service, right? Create 5 variations or whatever your company needs and provide that as a service. That's going to be even more useful because used by more people, right? So, but that goes back to the adoption, right? It's not how many people sometimes go somewhere, but ideally that platform would be used every single second of somebody's life, right?
Yeah, so I think you're kind of describing like the platonic ideal of the platform really is like a, GitHub and Slack and IDE all combined. It's the place developers go to in the morning to figure out what does my day look like, what work do I have to do today, and they're using it all day until they finish for the day. Switching gears here a bit, Viktor, we've talked a lot about this idea of there's no one size fits all, every team is different, and I think that's very true. So I'll kind of put 2 questions in front of you here related to that. One is, do you think that platform engineering is a good fit for all teams or only some types of teams? Is there a certain level of scale that you need to kind of achieve for it to be a good fit? And second question here is kind of what teams do you think is platform engineering a good fit for or not a good fit for? Are there any general heuristics that are good to keep in mind when evaluating platform engineering as a potential strategic decision for you? How do you decide this is something I want that's a good fit for my company?
It's a combination of needs and numbers, right? I would never put something in a platform that serves a team, because that's kind of waste of my time, right? Because, hey, if that team has something very, very special that only that team needs, then that team should be able to develop whatever they need, right? I'm from the platform perspective in business of serving as wide range of users as possible. Just like any other business, right? So it's really mostly a game of numbers. You have 1,000 people in a company. What is it the thing that you can that can be very useful for 900 of them, not for 2 or 1?
Gotcha. So really a game of scale here, kind of following typical programming principles. Make sure you're able to be repeatable. Don't repeat yourself. Keep it simple. And I think implicit in that is larger teams. There's a lot of platform engineering already happened kind of at the Fortune 500 or the kind of larger enterprise level. And I think we're starting to see it seep down into smaller teams. It's starting to become accessible to other enterprises or even SMBs. Curious, do you have any thoughts on that trend of platform engineering becoming increasingly used by smaller companies?
Yeah, actually, I just remember that at the very beginning, I started one of the first answers with, "Yeah, I'm going to start with big teams," and never went down from there. The impact is much smaller, and the need is much smaller, and the return of investment is almost certainly not there when we're talking about small organizations. Teams can be small, but you can have many of them, right? Small organizations, simply because there's a plethora of services that you can use right now to accomplish something that is very good for small teams, right? Going back to Heroku, for example, which I'm not sure whether it's still alive or not. And today you have other services like, questionable. You have other services like Fly.io and quite a few others, right? You have also, in big providers, you have things like Google Cloud Run, for example, right? That will simplify, give you what you need without you spending 3 years trying to figure out, right? For smaller organizations, those services are working fine and they're doing what they need to do. And if you're small, you can adapt. And this is the key now. You can adapt to them. You can say, "Hey, Fly.io ask me for code or container image, and it runs my application, and it scales my application. That's absolutely amazing. I might not be able to use my application as is, but I can adapt to it," right? Now, big ones cannot do that because they have 20 years of stuff from mainframe until whatever they're doing right now, right? The bigger you are, the less you can adapt. And that's the reason why you see a huge difference between those services I was mentioning before and, let's say, AWS, right? AWS actually does not give you a service that is ready for you to consume. It gives you building blocks that you need to assemble to get what you need. And that gives you flexibility to get exactly what you need, right? There is no such thing as EKS cluster. There is EKS cluster that requires a node pool or multiple node pools and requires subnets and VPCs and internet gateway and a bunch of things, right? And when you assemble all those things, you get more or less exactly what you need. But that does not work for smaller organizations. It's almost silly to go down that route because I just need a cluster. Don't give me all that nonsense, right? So for smaller organizations, just go for ready-to-go services, especially with smaller providers. You just need to spend time to find out which service is closest to what you need. Forget about platform engineering.
Yeah, and one interesting thing, especially amongst bigger teams, is you make a great point. The bigger you are, the harder it is to adopt new technologies. Everyone wants to stay cutting edge. Who doesn't? But it's easier said than done when you're operating at a massive scale. One benefit of platform engineering that we've seen is you can define services at a higher level and allow for these opaque migrations where you swap out the underlying technology. For example, maybe you're using Postgres today and you have a DBA team that manages Postgres on some on-prem infrastructure somewhere, and everybody in your engineering team uses your developer platform to requisition Postgres instances that this DBA team satisfies. Maybe you decide, hey, actually, we don't need to be managing this ourselves. We're going to switch to using RDS. If you're able to make RDS satisfy the same Postgres implementation, the app devs don't need to know. They don't even need to care. They can just go and request Postgres, and now it's RDS. It's all in the same interface. And I think I've seen this with a couple of AWS services a few times. RDS is, I think, an easy example. But this idea actually, I think, extends to the platform as a service world. What if you could define a interface for a container? This is how every app dev spun up containers in your company. And today that's being powered by ECS or Fargate or something like that. But maybe tomorrow it's going to be powered by Fly, and you're going to swap out to some platform as a service managed offering. I think this is a really interesting path for larger companies to actually bring in cutting edge technologies more and more often, which is a pretty exciting trend.
That's in a way crucial, right? Because it's almost the same logic when we're talking about end user applications, right? The key is always the API, right? That's something you need to really, really think through because that's something that is very hard to change. Now, implementation of your application behind that API you can do 75 iterations every day and you're still fine, right? Assuming that you don't break it and things like that, right? Because the API is what others are through which is something through which others are consuming you. And I see those services the same, right? You need to think really well, what is the API? And I'm using API in a very broad sense now. That can be a web interface or anything, right? Through which somebody is going to consume the database. Now, whether you use self-hosted today and then switch to RDS, and then because of some money issues, because it's too expensive, next day you switch to some other solution, that's your problem. You promise that I have this interface to manage the database. Yeah? Excellent. That's what I'm using. How you handle things behind that is completely relevant to me.
It's a massive value of platform engineering, being able to create these things. And I mean, this isn't necessarily a new idea, the idea of creating abstractions within your stack. I think it's one of the ideas that led to the idea of the microservice architecture. But it's taken to a greater degree and applying it actually to your infrastructure. I think these are really going to help bigger teams in adopting specialized services. I think Fly is a great example where we can look at it and say, 10 years ago, you couldn't have had a specialized team for managing container infrastructure. Hell, containers didn't even exist 10 years ago, so how could you have possibly had that team? But there were companies that were building massive, legitimate scale companies at that time. They are completely precluded from using these new technologies. And I think this might be a place where platform engineering provides a path for you to be able to swap out some of the older pieces of your stack and bring in new tools. This is going to be a really interesting trend over the next couple of years of, are bigger companies going to get much better at adopting new technologies? That's going to be pretty massive.
I think that's the big shift or change that we're experiencing right now. Because in the past, it was usually that platform engineers or whatever that was called, in people providing services internally, usually was, hey, I'm giving you Jenkins, right? And then once I give you Jenkins, that's it, right? It's there forever. I mean, or whatever, I'm not now trashing Jenkins, but whatever the tool is, right? Now we're talking about building those interfaces, right? There is something between you and my implementation, right? And that something is agreed upon and serves your needs. The rest is...
And that's all the difference,
exactly.
Right? Well, and I know we've spoken a bit about Kubernetes and CRDs and how that really enables this trend of platform engineering right now. I want to talk about another trend that we're seeing in the technology space right now of infrastructure as code. Seeing more and more contenders going to try to dethrone Terraform, entering the infrastructure as code world. I think Bloom is a notable call out here. And a lot of the ideas of infrastructure as code come from a similar place as platform engineering. These ideas of standardization, have your configuration stored in version control, have your configuration fully renderable as a config file, and have repeatable, reusable modules that can represent your infrastructure. So I'm curious, how do you see platform engineering and infrastructure as code intersecting? Is there anything interesting going on in that space that's worth mentioning?
We are reaching yet another end of era of those types of tools, which might stay under the same name or change, but that I can bet anything that the next generation of what we call today infrastructure as code tools are going to be managed by Kubernetes precisely because of the properties that we talked about and some others that we didn't. Like one just first thing that comes from the top of my head with the existing tools or more established tools for infrastructure as code, like there is no API. Like I cannot say, hey, tool X without naming any. What are all the nodes that I have in my system? Or give me a list of databases, or tell me what's happening, right? So there is no API, there is no continuous reconciliation, drift detection and reconciliation, and so on and so forth, right? And we do not necessarily need to build that next generation with Kubernetes. We can build it in many, many different ways. But if we do it in many, many different ways, we will have to redo years of development that was already spent in Kubernetes. Again, hey, your infrastructure as code needs an API. I can build one from scratch, make it extensible, create a specification, figure out how providers are going to extend that specification, stuff like that, or I just plug it into Kubernetes, right? I can figure out drift detection reconciliation by myself, or I can let Kubernetes do it, right? So those things are, the next generation is almost certainly going to be Kubernetes. And now I'm biased, so my main focus is crossplane. But if you ignore crossplane for a second, right? If you look at what is AWS cooking right now, or what is Google cooking right now, or what is Azure cooking right now, those are the same types of tools. They're all going into, and not only hyperscalers, VMware as well, right? The good example is Cluster API, right? Which is right now a kind of a standard that almost all vendors that are somehow related with managing Kubernetes adopting, right? So everybody's going in that direction. So it's coming for sure. I mean, it's already there, but when I say coming, I mean, we will see a similar shift that happened from what we called configuration management and later got as what we call infrastructure as tool. Now, people are going to start screaming at me and so on and so forth, but configuration management tools and infrastructure as code tools have the same goals. It's just the principle change, so what they do is differently, right? And now we're going into yet another iteration of those things.
Yeah, I love that you really see Kubernetes as this, not just compute abstraction, but it seems like a general resource reconciliation platform, if that makes sense. It seems like you really think the future here is Kubernetes, controllers, CRDs, maybe infrastructure as code has some way to import resources in, but fundamentally Kubernetes is the engine that will power the future.
Yes, because what we got with Kubernetes is something that never happened before. Most of us, and when I say us, I mean vendors or people working on projects, agree that that's the place which we are going to extend with our products. That never happened before. You had a huge community. I'm going to repeat same examples as before. You had a huge community of Ansible that was contributing a lot and extending it, but that was limited to Ansible, limited to some other project and so on and so forth. This is the first time that we all agree that this is it, right? Now, what confuses people, I think, is that the first implementation of controllers
a little too container-centric
in Kubernetes happened to be those managing containers. And somehow, most of us we got to the logical conclusion. So, if from day one, what Kubernetes does is manage containers, hence, this was designed to manage containers. It's not, right? And you can see that with what came later. Like, if you look at KubeVirt, it's managing your virtual machines in same cluster. If you look at, but like right now, we're getting Wasm supported in Kubernetes, right? We have, again, Ingress that manages external load balancers. We have storage, again, managed somewhere else, leading me to Crossplane, which what we are trying to do is manage things outside Kubernetes. That was always the goal. I mean, that was not the goal in itself. The goal was always to bake few controllers into Kubernetes to show people what you can do, and then let the world extend that functionality through additional controllers, right? That do whatever you want to do. And I'm willing to place a bet in any amount right now that I don't know really what will happen in the future, but I can bet that Kubernetes API with CRDs controllers and so on and so forth are going to outlive containers.
Well, you heard it here first, folks. If anyone in the comments wants to take that bet against Viktor, which will last longer, containers or Kubernetes? We'll comment below. We'll run a poll and have to send the results back to you, Viktor. Well, Viktor, to end us off here, anyone who has spent any time in infrastructure has their fair share of war stories of things that have gone right, things that have gone wrong. I'm curious, for the audience here, do you have any stories you want to share about a time that maybe you wish you had a platform or a team that was not operating as it should be?
Oh, that was most of my life. I mean, I've been in the industry for a long time, 30 years probably, something like that. Depends whether you count my pirate days and more. And it was always, not always, but for a long time based always on waiting, right? I think that's a curse of being a developer, right? you're waiting for somebody to do something. So I always wished I had a platform that I could use to accomplish something that is not really necessarily my core competency, right? Now, situation got better over time. Like we got, when VMware came with virtual machines, it took us 5 years to adopt it, but that was all of a sudden, hey, I can create the server myself. Painful, yeah, it could take me a full day, but hey, imagine that was the beginning of just one day, because the alternative was me looking through the window, waiting for that truck to come with a new server, right?
Yeah, hope they clocked in today. It's worse than waiting for furniture deliveries, right?
Yeah, but when that server comes, it's still nowhere close, right? Somebody had to install operating system on that server, and somebody had to configure that server, and then you go there and you say, you know what, that's not what I needed.
Awesome. Well, Viktor, thanks for coming in chatting with us today about platform engineering. For anyone interested in learning more about you, where can people go to learn more about you or more about your content?
Oh, I'm everywhere. I have a YouTube channel. I have a podcast. I speak in events very often. I'm present in at least dozen open source projects, 50 different Slack channels. If you just Google my name, you'll find me. Easy.
Awesome. Well, everyone, this has been awesome. I've been your host, Johnny Dallas from Zeet. I hope you enjoyed learning about platform engineering today, and hope to see you next week for our next episode. Thank you.
Thank you for having me.